Unit 4, Section 4, Solving for Y. So much of algebra involves graphing, and you know what? Graphing is so much easier when you solve for Y that this is one of the major skills that you're going to learn throughout the whole course. It's so important. And if you talk to Algebra 2 teachers, they're like, I just wish they could solve for Y. So we're going to learn, we made this its own section, so we're going to learn how to do that today. The goal essentially is to take some of these equations. Look, see this equation? Yeah, this is called standard form, where you have the x and the y at the beginning and then it equals some number. All right, we want to get y by itself. And these are actually equivalent to each other. They're the same thing. All right, the x's and y's that solve the first one, the pairs of x and y's, the solutions, will also solve the second one. It's just writing it differently. It's like writing 12 over 4 and 3 over 1. They're equivalent. You just write them differently, and that's what we're going to do. We're going to take equations, and we're going to write them. We're going to rewrite them so that the y is by itself, the x term is next, and then the number is by itself at the end there. So let's do some examples so you can see what we're talking about. The first type, just have a coefficient in front of the y. And so we're going to solve this using the same skills that we learned in the last unit when we solve equations. Like if we were solving for y, if we wanted to get y by itself, we wanted to get rid of the 2. This is 2 times y. We use the opposite operation. What is the opposite of multiplying? It's dividing. So we're going to divide by 2 instead of multiplying by 2. That'll get y all by itself. So in this example, we just divide everything by 2. Now, some teachers draw a whole big line, so it looks like this. Let me show you. And this is a bad idea. They draw the big line all over 2. Don't do that. That's bad. And the reason why is we want to separate this into 2 different parts so that we can simplify each. And we put the equation in what's called y equals mx plus b, or slope-intercept form. And again, this is all to help us graph. And graphing is a huge deal in algebra. And so that's why we want to avoid this whole big division line, and we want to do each individual term by it. All right, back to the example. Here we go. So the 2 over the 2 cancel. You get y. You get an equal sign. 4 over 2 is 2. The x hangs out. And you have a negative 10 over 2. That's negative 5. So this equation is equivalent to the equation that was given, except it is now called slope-intercept form. It's in y equals mx plus b. So your directions from here will just say solve for y, so that's what we're doing. Let's look at number 2. Okay, with number 2, 5y plus 40 equals 20x. What we want to do is get rid of that 40 first. Okay, we don't want to divide by, well, we could divide everything by 5. Hey, we could do that. But let's get rid of the 40 first. What's the opposite of plus 40? Minus 40. So to each side. Now here's where students get confused. The equal sign's here, so I'm going to draw the line down the middle. All right, so on the left, you get 5y. They cancel. Equal sign. 20x minus 40. They're not like terms, so you can't combine those two and get like a negative 20. That doesn't work. So you have to write them separately as 20x minus 40. It's just like that. All right, then we can get rid of the 5 in front. We divide everything by 5 because it's 5 times y. The opposites divide. So they cancel, and we get y equals 20 over 5 is 4x, and then you get a minus 40 over 5, which is 8. And that one is all solved. Hey, how fun is that? Let's try the next one. All right, number 3, you have 4x and a minus 6y equals 12. All right, first we have to get rid of that 4x. So is that 4x positive or negative? That's a positive 4x. How do we get rid of it? We have to subtract 4x from each side. And the same thing happens in this one that happened in the last one. We get 12 minus 4x. Well, you can't do 12 minus 4x because one has an x and one is a regular number. All right, so let's go through and see what we get. The 4x minus 4x, they cancel. Do not forget that negative in front of the 6. That is a negative 6y equals, and then I always write the x term first. I think you should do it because, again, of this slope-intercept form, which we're really going to harp on in Unit 5. So, what's our x term here? It's negative 4x. You can't do 12 minus 4 is 8, again, because these aren't like terms. One of them has an x, and one of them does not. So you can't combine those. So you write the x term first, and then you write the number term, the term that's all by itself. All right, so I'm going to explain that again. We got to get rid of the 4x first. So we do minus 4x from each side. They cancel here. You bring down a negative 6y, the equal sign. These don't combine because they're not like terms. So you just write the negative 4x first and the positive 12 second. All right, so now what? We have a negative 6 times y. The opposite is to divide by negative 6. So we're going to divide each term by negative 6. These cancel out, and we're left with y equals. All right, so negative 4 over negative 6. That reduces to 2 over 3. So we get 2/3 x. That x in the top can just hang out in front. And we have 12 divided by negative 6 is a negative 2. So this question is the answer is y equals 2/3 x minus 2. All right, so I've selected 3 different problems for you to try. Try these 3. Pause the video. Please pause the video and try these 3 all by yourself. I will tell you that number 1 is like the first example. This one here is like number 1 up here. So they're very similar to each other. And number 2 is like number 2, and number 3 is like number 3. So go ahead and try those 3 right now by yourself. Pause the video. Let's check it out. Number 1, all you have to do is divide everything by 5. Divide by 5, divide by 5, divide by 5. And then simplify those numbers. And there we get a wonderful 2x plus 5. So y equals 2x plus 5. In number 2, you have to get rid of the minus 20. So the opposite is plus 20. So you add 20 to each side, then you divide by 5. All right, so what's that going to give us? Add 20 to each side. Remember, they don't combine there. That's why I changed colors. They don't combine, and then you divide each side by 5, you get 3x plus 4. And for number 3, subtract 5x, you got to get rid of the x term, so that's a positive 5x. The opposite is to subtract 5x. So you subtract 5x from each side. These are not like terms, so I'm going to write negative 5x plus 25, and then you divide by negative 2.5, divide everything, and you get 2x minus 10 for that one. Hey, I have 3 more for you to try. Go ahead, pause the video, try those. Something weird happens with each one of these, or at least with one of them. So give it a shot, pause the video, go! Okay, so I'm going to work through these actually. I hope that you've given each one of those a good shot, and we'll see if you get the same answer that I get. Number 1 I picked because of that minus y. You have to get rid of the x first. This is a positive 1x. It's plus 1. So you have to do the opposite, which is minus 1x, or just minus x. So you subtract x from each side. Here's the line down the middle. And so the negative y comes down equal to, and I always write the x term first, plus 10. Remember, they don't combine because they're not like terms. You have to get rid of, here's the problem. I picked number 1 because of that negative in front. You're not done yet. It's not solved for y. It's solved for negative y. That's the opposite. So we need to get rid of it. So how do you get rid of a negative? You can divide by negative 1. So divide everything by negative 1. Everything you got. So you're left with y equals positive x minus 10. And so that's going to be the answer for number 1 there. All right, let's try number 2. I'm going to show you something different with number 2. I picked this one because you can subtract the 2x and then add 21 and then divide by negative 3. But in this one, it's quicker if you want to add 3y to both sides of the equation. Here's where that line comes in handy. So I'm going to add 3y. You're going to be like, Mr. Kelly, why are you adding 3y? We have never learned how to do that before. Look, minus 3y plus 3y goes away, so we're left with 2x minus 21 equals 3y. Now you can divide by 3 because it's 3 times y. The opposites divide, so divide everything by 3, and we're left with 2/3 x minus 7 equals 1y, or y equals 2/3 x minus 7. It's the same thing. All right, so the reason why I did that is because, look, all 3 terms, the x, the y, and the number, are on the left-hand side. If I can move the y over the equal sign by adding 3y to each side, that gets rid of it there and adds it to the right. Okay, that saves me a step. Now, you don't have to do it like that, but you do have to get this answer. So if you did it a different way and you didn't get that answer, you need to double-check yourself or ask your teacher. All right, and how about this one? Number 3. Number 3 is kind of weird. The y's over here. I'm going to get rid of the x. All right, so minus 6x. We got to get rid of that first. Here's the equal sign. The minus 6x on this side. Draw a line. 6x minus 6x, they cancel, and you're left with a 0 equals 7y. So now to get rid of the 7, it's 7 times y, we divide. So we divide each side by 7. You're left with 0 equals y. That is slope-intercept form. It's solved for y. It's all set. It's the same as this. Y equals 0x plus 0. It's got the same numbers they have here, except they're just equal to 0. And so we're just going to simplify it and keep it y equals 0. So that is it for Unit 4, Section 4. We're all done with there. No application problems to work through, but I think you can figure out the application problems that are on the packet are very similar to these problems. There's not much more than solving for y. So that's it for Unit 4. You're all done. Go practice, and hopefully you'll pass those mastery checks no problem. This is Mr. Kelly signing out. Remember, it's nice to be important.